This video assumes that you already understand the integration and derivation of the sine and cosine functions. So I'm just going to start with tangent. The integration for tangent is pretty straightforward. You rewrite your tangent as sine over cosine. It's just a standard understanding that sine over cosine is equal to tangent. Then you do a u substitution of cosine x. Now, this integral is not in standard form because we're missing a negative, so I'm going to multiply by negative 1 over negative 1. Rewrite this as the integral of... And then I'm going to find my du, which is just negative 1 times sine x times dx. And my u is going to be cosine x. And because I have a leftover 1 over negative 1, which is just negative 1, I'm going to rewrite this as the negative integral of 1 over u du, right? I got my du from negative sine dx. My u is just cosine. And that is very simply negative ln the absolute value of u. And I'm just going to sub my u back in right now, but the absolute value of u is going to be absolute value of cosine x plus c, right? All I did here was I subbed back in my u as cosine x. Now let's do the next one. We're going to do cotangent. Right? Cotangent is just simply the 1 over tangent, or the inverse of tangent, which means it is also equal to cosine x over sine x dx. So I'm going to do a u substitution of sine x so that my du is going to be equal to cosine x dx, right? The derivative of sine x is just cosine x. And then I can rewrite this, right, as 1 over u du, right? My du was cosine dx, so that gets canceled and turned into a du, and my sine x was 1 over u. And the integral of 1 over u, or just 1 over x, right, it would be ln absolute value of the denominator, that u. And that u right there is a sine x, so I'm just going to sub back in my sine x. So my final integral is ln absolute value of sine x plus c, right? And that's tangent and cotangent. Now, secant is a little bit trickier. Right? The integral of secant requires that we multiply by 1. This is a technique that was learned in the overview of advanced integration techniques, right? But we can just multiply our integral of secant x by 1. This doesn't change the value of our integral at all whatsoever. It just multiplies by 1, and it allows us to rewrite our secant x expression as something with a numerator and a denominator. And you'll see why we chose this particular multiplication by 1. It looks kind of arbitrary and complex, but it has function, right? So I'm going to distribute that secant. Right, so all I did was distribute that secant. And then I'm going to do a u substitution, right, with secant x plus tangent x. And my du is going to be equal to, right, the derivative of secant x is just secant x tangent x plus the derivative of tangent x. And the derivative of tangent x is just secant squared x, right? All of that times dx. And now, you know, we're left with a very easy to integrate expression, because what we can do right here is we see in the numerator that we have a secant squared x plus secant tan x, right, which we see right here, and we got our dx. So this whole numerator and that dx gives us a du. So we can write this as 1 over, you know, something times du, right? That gives us a du. And our u is just secant x plus tan x, and we have that in our denominator. So we can write this as 1 over u. And when we integrate 1 over u, we're going to get ln absolute value of u, and I'm just going to sub my u back in here. So ln absolute value of secant x plus tangent x plus c. And that is our final integral for the secant x. Now the cosecant x, right, is very similar to the secant x. You're just going to multiply by right? And then when I distribute that cosecant x, I'm going to get right? As you can see, all I did was I distributed that cosecant squared x, that cosecant x to the cosecant here and the cotangent there, and I have the same denominator there. And then I'm going to do a u substitution of cosecant x plus cotangent x, right? And then that also means, right, that my derivative with respect to u, my du, is just going to be the derivative of cosecant x, which is negative cotangent x cosecant x, getting kind of small in space here, and the derivative of cotangent x, right, plus the derivative of cotangent x is just going to be negative secant squared x. So we're going to get minus secant squared x, and then we're going to pop my dx over here, just like so. Now if you look closely, you'll see that our numerator almost comes close to our u substitution. The only difference is we have a positive cotangent cosecant and a positive cosecant squared x, right? So similar to our, what we did with our tangent function, we have to multiply by 1. So I'm going to go negative 1 over negative 1 times that whole integral, right? This whole integral right here. And I'm not going to rewrite it. But in order to get my du, right, so we're going to go 1 over u du, right? In order to get this du right here, I had to cancel out that cosecant squared x plus cotangent cosecant x multiplied by negative 1, right? So that negative 1 gets taken out. And I did that because if you distribute a negative 1 into cosecant squared x plus cotangent cosecant x, you're going to get negative cotangent x cosecant x minus cosecant squared x, right? You're going to get your du. And so that dx is going to cancel out, and that right there is going to cancel out, and it's going to cancel out with that negative 1, and it's just going to give you your du, right? So I wrote that as 1 over something times du. And then my u is just cosecant x plus cotangent x. So this can be rewritten as negative 1 over u du, right? Which is equal to the negative ln of the absolute value of u, and I'm just going to sub my u in here, which is going to be cosecant x plus cotangent x plus c, just like that. And that is my final integral for that one.